Hi, future doctors. Welcome to the next class. In this class, we will discuss about force between two charges. But already we discussed force between two charges, but this is small difference will be there. What is the difference means? Because we have discussed continuous distribution of charge. 1 point charge will be there. 1 point charge is going to be, let us assume, small q. Point charge is going to be small q. And a linear charge wire, which is positively charged, which is positively charged. A linear charge wire, which is positively charged, which is having linear charge density lambda, and total charge on this capital Q, and the length of this one is going to be capital L, and it is going to be placed at a distance small a from this charge, this end. So let us assume AB is the linear charge wire. Then what is the force between this point charge and this wire? Generally, we will write our formula. F is equal to K Q1 Q2 by R square. If you want to use shortcut for this, directly we can write, so K into F is equal to, so K into, I will write generally Q1 Q2 by R into R. So K, what is Q1 now? Small q. What is Q2? Capital Q. What is 1R? This A is at a distance small a. Another one will be this B is at a distance. How you will get? A plus L. This is the answer. This is shortcut we can get. But generally if you want to do, but it will be little bit lengthy. How we will take means, on this charged wire, we will take, on this charged wire, we will take small portion. The small portion is at a distance. The small portion is at a distance x. Small portion length is going to be dx. Small portion length is going to be dx. On that how much charge is going to be there means, on this how much charge is going to be there means dq. Then what is the definition of lambda we said? dq by dx. What is the total charge? Q by, what is the total length? L. So this is the distribution of charge. We have given the definition. The total charge is available on total length, but on dx length how much charge is available? Only dq charge. Now this is q, this is going to be dq. This yellow color one is going to be dq. Q and dq separated by how much distance? X. Now the force between these two, F is equal to K into Q1 is Q, Q2 is dq. So what is the separation? X square. Whenever you are writing this is dq, force also you have to write df. This is small amount of force. If you want full force, you have to integrate both sides. Whenever you are doing integration, this x is changing from, see, this x we are starting from a and ending at b. Therefore, initially x is changing from a to finally a plus l. So between the limits a to a plus l, you have to integrate. So integral dx is nothing but x. What is integral dx? X. Therefore, what is integral df? F. Now k cube integral 1 by x square. What is dq? What is dq from this means? Dq is equal to lambda dx. Lambda dx, because lambda is dq by dx. So k, q, lambda is constant, x power minus 2, lambda dx, not dq. Isn't it? In place of dq, we are writing lambda dx. X power minus 2 dx. Correct? Now, if you do integration for this, what is the limits? Between the limits a to a plus l. So, between the limits integral a to a plus l, and left side how much is there? Kq lambda. So, Kq lambda x power minus 2 dx. What is the integration of this one means? Kq lambda x power minus 2 plus 1 by minus 2 plus 1 between the limits a to a plus l. So, Kq lambda x power minus 1 by minus 1 between the limits a to a plus l. So, this minus you can write here minus kq lambda 1 by x a to a plus l. First we have to limit, which limit we have to substitute? Upper limit. In basics we gave simple differentiation, simple integration, there we said. First we have to substitute upper limit. Next we have to substitute lower limit. So minus kq lambda, what is LCM? A into a plus l. So a minus a plus l. So if we expand kq lambda, so a minus l by a into a plus l. This plus a minus a will be cancelled. Then what is remaining for you people means? So what is remaining? Minus kq lambda, so into minus l divided by a into a plus l. But if you observe here, we wrote answer in terms of capital Q, small q, a into a plus l. What is lambda? We said lambda is nothing but q by l. Now what is in place of lambda? What we can write? Q by capital L. Capital Q by capital L. Now substitute here. Minus into minus plus. Kq, q by capital L into L by a into a plus l. This l and l will be cancelled. Now see your final answer. You got kq by a into a plus l. This is the force. But already we got here. So you will be saving entire your time to calculate this by remembering this logical equation. So not only here, the same question you will be getting in gravitation also. Gravitation, how you will get? What is the gravitational force between mass, small m point mass, and wire? This is having mass capital M, length L. So separated by distance A. Now what is the gravitational force? They will ask. So for the same question, we have taken for the charge Q, L, so which is at a distance A. This wire is getting distance separation from A to A plus L. So here this wire also is going to get distance A to A plus L. A to A plus L. Therefore, in this we got force K small q capital Q by A into A plus L. In this also you will get same gravitational force. This is electric force. In place of K you will get here G small m capital M by A into A plus L. This is 1 plus 1 half. If you did this one in gravitation already previously, then in this lesson directly you can write this formula very easily. Isn't it? I think it may be helpful for you people, I am thinking. So this is how to calculate force and how to remember logically the force between these two charges. One is point charge, another one is extended charge. This is continuous charge, distribution. I hope you people understood. Thank you.